Hello guys, welcome back to my YouTube channel, Just for Math. Okay, in this video I would like to show you guys how to identify and solve a quadratic sequence. But before I begin, I would like to explain the meaning of sequence. In mathematics, a sequence is a list of ordered numbers, right? And we have basically four types of sequence, which are linear sequence, which is also known as arithmetic progression, exponential sequence, which is also referred to as geometric progression, harmonic sequence, and Fibonacci sequence. Okay, in this video, however, my focus is on quadratic sequence. But looking through the lists we have on my screen, you discover that quadratic sequence is not listed. However, it's best seen or known to be a type of linear sequence. But if you think about it, linear and quadratic functions in mathematics are two different things. However, we can look at a quadratic sequence to being a special type of linear sequence. You know why as we progress. So when we say quadratic sequence, it is actually a sequence that has a common second difference. Okay, any sequence with a common second difference is referred to as a quadratic sequence. So let's quickly form one type of quadratic sequence, an example of a quadratic sequence, for you to get a clear picture of what it is before we begin talking about how to solve. So now let's see how to identify. I've given you a definition. It's a sequence with a common second difference. Let's construct one example of quadratic sequence, then I will describe how to solve a quadratic sequence. When I say solve, I mean how to actually solve for the nth term of a quadratic sequence. So let's just construct one. Okay, let's say the first term of the sequence we're about to construct is 2. Okay, 2, let me add 3 to 2, that'll be 5. So it means the first difference is 3. Okay, I mean when I say first difference, I mean the difference between second term, the first term and the second term here is 3. Okay, let's add 2 to 3, making 5. 5 plus 7, like 5 plus 5, that is 10. So it means we have the second term 10, and difference is 5. We add another 2, that is 7. 7 plus 10, that is 17. Alright, so 7 plus 2, 9. 9 plus 17, that is 26. And it goes on and on and on like that. Okay, what you observe here is that we have a first difference of 3. We have a second difference of 5. We have a third difference of 7, and we have a fourth difference of 9. So with this, you would notice that there is a second common difference of 2, a second common difference of 2, and a second common difference of 2. So whenever you see that a given sequence has an increasing or decreasing first differences with a second common difference, such a sequence is referred to as quadratic sequence. All right, quadratic sequence. So this is how to identify a quadratic sequence. Now, when you are given such type of sequence, how do you solve for the nth term? Okay, just like we know that for linear sequences or arithmetic progression, there is a formula for nth term, which is given by, so for linear sequence, we have a formula given by Tn equal to a plus n minus 1d. Right, this is for arithmetic progression. For exponential sequence, which is geometric progression, we know the nth term Tn, which is given by a r raised to power n minus 1. Also, for quadratic sequence, let's call it QS. For quadratic sequence, the nth term is given by an squared plus bn plus c. In fact, let me write this more legibly. So the quadratic sequence is given by an squared plus bn plus c, where a, b, and c are parameters that can be solved using the following equations. So the first is 2a equal to the second difference. Okay, so this is the first equation that you need to solve the first parameter in the quadratic equation, that is a divided the parameter a. And second equation is 3a plus b equal to the second term of this of the sequence minus the first term. So this is the second equation that you need to remember. Then finally, a plus b plus c equal to the first term, which is this equation, the third equation. So with these three equations, you can solve for the parameters a, b, and c, which will be substituted in this nth term of a quadratic equation. So in our special, or in our particular case, in this particular sequence that we're able to generate or construct, the value of the second difference is 2. All right, and t2 minus t1, t2 is 5, t1 is 2, t2 minus t1 is 3, and a plus b plus c must be equal to the first term 2. Okay, so this is how to go about solving a quadratic sequence, and also how to identify it. Okay, in a second video, or the second part of this video, I'll show you how to solve some special or some particular examples of quadratic sequence. So make sure you connect with me, or make sure you subscribe to my YouTube channel, click on the notification button to get notified when I post the video, and also like and share this video. I hope you guys enjoyed this video. Okay, I'll be looking forward to seeing you guys in the next video. Thank you very much, guys, and have a wonderful day. So I'm going to end right now and continue in the second video. Bye bye.